Hey there. Ever wonder how AI decides which answer is better when it's not human? Today, we're diving into a groundbreaking approach to AI evaluation that's making systems smarter, faster, and way less biased. Let's unpack this. Here's the core challenge. Large language models, LLMs like GPT or Claude can generate text, but how do we know if they're actually good at it? Traditionally, there are two evaluation methods. The first is absolute scoring. Think of it as giving a recipe a 110 rating. It's simple, but here's the problem. Different AI judges might rate the same response completely differently. It's like asking 5 chefs to rate the same dish. Results could vary wildly. Then there's comparative scoring, where the AI doesn't rate a response on its own. Instead, it compares two options and says, this one's better. This method is more reliable, but it's super time-consuming. Why? If you have 100 responses, you need to compare every possible pair. 10, 0, 0, 0 comparisons. That's like trying to rank 100 recipes by tasting every possible pair. Not efficient, right? Enter the product of experts, PoE framework. Think of it as a team of specialists. Instead of one AI judging everything, you let multiple models focus on small parts of the problem. One expert might compare response A versus B, another checks B versus C, and so on. By combining their insights, you get a full ranking without checking every pair. It's like solving a puzzle by putting together pieces instead of starting from scratch. But here's the twist. Researchers didn't stop there. They made PoE smarter by improving uncertainty estimates. Imagine if your AI could say, I'm pretty sure A is better than B, but I'm not so sure about C versus D. This probability of reordering lets systems focus on the most uncertain comparisons, cutting the number of needed checks by up to 50%. It's like prioritizing the trickiest parts of a puzzle first. They also discovered that mixing absolute and comparative scoring works wonders. Absolute scoring gives a quick snapshot, while comparative scoring adds depth. Together, they create a more accurate picture, like using both a thermometer and a barometer to predict the weather. The real magic. This method isn't just about speed. It's about efficiency. By understanding where the AI is uncertain, systems can prioritize their efforts, saving time and resources. And the best part, the specific model used doesn't matter as much as the way uncertainty is measured. But here's another layer. AI models can be overconfident. Imagine a student who's 90% sure they aced a test, but actually only got half the answers right. That's called calibration error, when a model's confidence doesn't match its accuracy. Researchers tested models like Flan T5 and Qwen 2.5, and some had wild calibration issues. One Qwen model had a 28% expected calibration error, like a student who's always wrong but never doubts themselves. So how do we fix this? Think of it like giving AI a reality check. One method. Ensembling, combining multiple models or prompts, like asking a panel of experts instead of one person. It's not just about more answers, it's about balancing perspectives. The result? Fewer errors and a system that's harder to trick. Then there's Debiasing. Researchers tried two tricks. First, they'd ask the same question in different ways and average the results, like double-checking your work by approaching it from new angles. Second, they designed prompts that actively push the model to avoid biases, kind of like a coach helping an athlete stay focused. But here's where it gets really clever, rejecting uncertain answers. Imagine grading essays and tossing the ones that feel off. By filtering out the most unreliable responses, models like Qwen 2.5 became way better at ranking answers by quality. The key metric. Spearman rank correlation, a fancy way of saying how well the model's scoreboard matches the real-world quality of answers. The data. Wild. A technique called probability of reordering, which lets the model pick the most informative comparisons, outperformed others. It's like choosing the best clues in a mystery, instead of random guesses. And the numbers back it up. Huge jumps in accuracy, especially when paired with Debiasing. So what's the takeaway? AI isn't just getting smarter, it's learning to check itself. By combining models, refining prompts, and filtering out noise, researchers are building systems that are fairer, more accurate, and less prone to wild errors. And as this tech evolves, we're not just talking about better chatbots. We're talking about AI that can help us solve real-world problems with more reliability than ever before. Next time you interact with AI, remember, behind the scenes, scientists are working hard to make sure it's not just smart, but smart in the right way. Stay curious, and we'll dive deeper into the future of AI together.